examples of geoengineering. And this is not an exhaustive list, but these are some of the main ones. The one that's talked about the most, and is somewhat easy in some ways, is blocking sunlight. You only have to reduce the amount of sunlight hitting the Earth by about 2% to reverse the effects of climate change. And there's two main ways of doing that. The most talked about one is reducing smoke or putting sulfates in the upper atmosphere using planes or rockets or other things. And that's sort of what we know that will work because that's what happens after a volcano. And the Earth does cool down after a volcano, so for a couple of years until the smoke settles out of the air. So we know that will work. Now it turns out there's some kind of bad side effects, like one study showed that yes, you could reduce the temperature by a couple degrees, but it would stop raining in India and those kinds of things. Also, the problem with this is it's not solving the problem, it's just masking the problem. So once you start this, you have to keep doing it, and if you ever stop, the temperature 6 months later is going to spike up by a few degrees and then you're gone. So, if you don't have the budget to fly the planes anymore. So this is really just sort of at best a temporary solution, maybe to fix a short-term problem like the melting of the permafrost while you're doing other things to fix the CO2 in the atmosphere. Oh, I'm sorry, I should go back here. The other one is to build ships that take seawater and pulverize it and throw it up in the atmosphere and create low-level clouds. Ships do this anyway with their smokestacks, so they make small clouds. This would make big clouds, and you can put the ships where you want them, and you can be very strategic about that. So there's some interesting capabilities about that. The other thing to do, and this is somewhat controversial, is to put iron in the ocean. And iron is sort of a fertilizer for algae. It makes algae grow, and algae eats CO2, and then hopefully they die and sink to the bottom and stay there for a really long time if you do it in the right parts of the ocean. Recent studies show that it doesn't quite work as they hoped, that fish eat the algae pretty quickly and it keeps the carbon up near the surface. So more study needs to be done on this to see whether this is actually going to be effective. It's relatively cheap, though, compared to lots of other things. This one I actually kind of like. It's called biochar. And biochar is simply taking any plant material and turning it into charcoal. If you heat something without oxygen, it doesn't turn into CO2, it turns into C, because there's no O2, there's no air in there to react with. And so that's how they make, that's for 1,000 years, you put wood in an oven that's really hot, and you close off the vent so the air can't get in, and eventually it turns into charcoal. Well, that's good because you can take this charcoal and just throw it back down on the ground, and it retains water, it acts as a soil stabilizer, not exactly a fertilizer, but it helps plants grow. And so if you grow really large amounts of biomass, or just take all of the leftover biomass from corn or other plants and turn it into charcoal, it won't degrade into CO2. If you do this on a really large scale, you can actually suck carbon out of the atmosphere. And it's relatively cheap. There are issues. It does make gas, which you can use as a fuel. There's some, bad parts of the gas you have to deal with and things like that. But compared to a lot of other things happening, it may be one of the more benign forms of geoengineering. The most obvious thing to do is to reforest the planet. I have a friend who's working on a program where he gives solar cookers to families in India so that they don't go and burn the wood, the dead trees, or they cut the trees down. And they also don't have to walk for miles every day to get the wood. And he also gives them rechargeable flashlights so they don't have to burn propane. And he also gives them a free cell phone. And both the flashlights and cell phone are rechargeable only when the solar cooker is hot. So it kind of encourages them to do that. And then if they use the cell phone, they use the solar cooker, and they keep the cows off out of the land, then they get free cell phone minutes. And so this is he's doing experiments on this right now. It looks pretty promising, but this shows what happens when you keep the cows off the land for just a few years there. So it's the same shot, basically, just a couple years apart. So there's others. This one I actually kind of like. This is just building machines, big, expensive machines that just suck carbon out of the air. And then you compress it and you pump it underground where it came from in the first place. You pump it into old oil wells or aquifers and things like that. This will cost $1 trillion at least a year to run. And it will be the biggest bargain we ever had if we can do it. There are a bunch of people working on this right now. They're small prototypes and things like that. And there's a lot of issues actually to overcome. But this is, you know, when everything else starts to hit the fan, this is something that we're probably going to do. I actually think we should do, first of all, I think we should spend heavily on researching these now, because you don't want to find out that the bad effects are worse than whatever you were fixing on these things. So we should research them and understand them really well and pick all of the ones that seem like they'll work and try them all. And hopefully, even if this one can suck 100% of the CO2 we need to suck out, who knows, it might not work well. So let's also reforest. Let's also try biochar. Let's try them all and see which ones work and which ones don't work. So that's the good news, is that there are some things on the horizon. But again, if you use this as an excuse for not limiting your CO2, these won't save us. So that's actually some positive. This is like when I talked to the scientists working on this thing, it was sort of like the one uplifting kind of thing I've seen in a long time related to climate change. So there's some other good news. Supposedly, we're going to be passing a cap and trade law in the United States pretty soon. Again, it won't be enough, but it will start us in the right direction. It will also, no one else is really going to, China and India are not going to do much about this until we do. Although the Chinese are pretty smart about this. They're already the largest solar power producer in the world, making solar panels, and they're becoming the largest wind turbine manufacturer in the world. So they're already moving in this direction. They know it's the future, and they can just decide to do it. They don't have all the, I guess, lobbyists coming to them, stopping them from doing what's the right thing. So we're really being kind of dumb about all this by not pursuing it aggressively. But that's good news if we do that. Again, it won't be enough, but it will get us in the right direction. The other good news is that this is the biggest economic opportunity ever. We are about to change all of the energy and transportation infrastructure of the world in the next 50 years. That's a lot of money. We're invested in a company that's growing oil from algae to make fuel. Fuel is a $1 trillion a year business. And they think they'll be able to make it cheaper than fossil fuels in just a few years. That's pretty good opportunities. So there's a lot of opportunity out there. Now again, there's a lot of bad things going to happen. But if you understand what it is and what's happening, and you take steps to make it better, there's a tremendous economic opportunity. Now if you want to learn more about what I was talking about tonight, there's a bunch of good books. The Weather Makers is a nice overview. It goes beyond an inconvenient truth, covers lots of areas. Tim Flannery is a good writer. Speed and Violence is the scary tipping point stuff. It goes into 4 or 5 of the major tipping points, and it's scary. One book I highly recommend is 6 Degrees. 6 Degrees, as I mentioned earlier, explains what changes ppm and degrees C into what the world will be like at different temperatures. It should be required reading for every member of Congress. And then Climate Code Red is an interesting book. It goes into far more, it's like my talk, but it goes into far more detail, and it's referenced like a report with footnotes and things like that. You can go to the internet and download it. I think they do charge for it now, but it's pretty detailed if you really want to get into that. If you'd like copies of the slides or a video of me doing an early version of the talk, there's going to be hopefully a new one up on the internet soon, or you want links to references and the books and things like that, if you go to my website, climateplace.org, and you can download slides, and you should go around giving this talk yourself, tell everybody about it. And I want to thank you for listening and opening it up to questions. Yes. Sure. There you go. Again, if you go to climateplace.org, there's direct links to the books and things, and you get all that information. Yes.
I have to say, this is the first time I've been involved in a discussion like this in the context of the nuclear reactors. I'm also hopeful of solutions, but we can build nuclear reactors now. It's carbon neutral. It doesn't require that you do some reactions to carbon outside carbon out the air.
Well, I'm against carbon. Okay. What?
actually work for now. It's probably
Well, I should just mention for the, so everyone can hear, for the recording, that the question is, well, sort of the question, the comment is, why aren't we talking about nuclear reactors? Because they're carbon neutral and as a form of energy. First of all, I think CO2 is the most dangerous thing. And the risks of nuclear are nothing compared to those. So I am for doing anything, like building power plants everywhere, but on research to understand all these issues so that we make the right choices. Other people argue, and I agree with them, is that we have to really think about the amount of CO2 that's left to release in the atmosphere before we really got to get down to zero, and that has to be dedicated to building all the green technologies, right? If we just got